So that's just the basics for finding an inverse, which you have done in the past. Another thing I'd like to point out on your calculator is if you're looking at this graph of the original, let's go ahead and delete the second one that we typed in. If you go second, draw, and ask it to draw the inverse, which is choice number 8, you're going to have to type in function y1. Because the calculator can easily just flip-flop the x and y coordinates, it will draw the right part of the inverse. An inverse in its function is always symmetrical around the line y equals x. So then if we add that equation in there, you will see how it's symmetrical around that line. Those are all things that I hope that you remember from Algebra 2 and pre-calc. Okay, so now let's go back and talk about how this is going to apply to you in calculus class. If I ask you to find the derivative of the inverse at 3 of the function 1/4 x cubed plus x minus 1. If I ask you to find the inverse of that function, you're not going to be able to solve for y. If you switch flop the x and the y, you're not going to be able to do it. So there is a theorem that's going to help us do that without finding the inverse. So what we want to do is find the inverse derivative of x at x equals 3. I don't really like this notation, so I am going to say that g of x is the inverse of f of x. So my notation will look like g prime of 3. That's what we're going to look for. The theorem that we use to solve is the fact that g prime of x is equal to 1 over f prime of g of x. In other words, the slopes are inverses of each other. So if your slope on the function of f of x is 3, then on the inverse, the slope would be 1/3. Okay, so we're going to solve this. So if I want to find g prime of 3, then I'm going to put 1 over f prime of g of 3. The problem is I don't know what g of 3 is. I do know that f of x is its inverse function. So if it's the x coordinate on g, then it is going to be the y coordinate on f. So I want to know where 1/4 x cubed plus x minus 1 is equal to 3. Now, I am going to use my calculator to figure out what that point is. So I'm going to go back to my graph. And I'm going to type in 1/4 x cubed plus x minus 1, and I'm going to set it equal to 3. And find where they intersect. Second, calculate, choice number 5. Enter, 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 and I get the coordinate point 2, 3. So on my f function, I get f of 2 is equal to 3. If f of 2 equals 3, then that means g of 3 equals 2. I can go back to my formula and put in 1 over f prime, and now instead of writing g of 3, I know g of 3 is 2. So all I have to do is find f prime of 2, and I know that the inverse function will be 1 over that value. So I can find f prime of x by using the power rule. It will be 3/4 x squared plus 1. I plug in 2. 2 squared is 4, times 3/4 will be 3, plus 1 will be 4. So I plug in 4 for that value. So the derivative of the inverse at 3 is 1/4. I'm going to go back to the graph. I'm looking at the graph there at 2. Let's go ahead and go second calculate. Choice number 6. I'm going to plug in 2. I get the slope is equal to 4, which means on the inverse function, the slope at 3 is 1/4. If I look at the inverse function, if I go to the point at 3 on the inverse function, I can see that the slope does look like 1/4. Okay, so that's your lesson for today. I would like you to look at number 71 on page 349. Number 71 on page 349.